move directly into our next session. Here comes my friend Andrew up front. Our next session will address how to integrate new equipment into older areas of a grain facility. And I'm really excited to hear this one. A facility real close to our family farm that we deliver grain to. I just recently learned that their original structures were built in 1896 and are still being utilized to this day. Andrew Knapp is the Director of Business Development for Hargrove Engineers and Contractors, where he supports the company's 19 offices remotely from the greater Chicago area. He's an experienced mechanical engineer and project manager with more than 3 decades of experience in bulk material handling, project management, engineering support across various industries. Now, on a personal note, I only learned in recent months when Andrew and I connected via LinkedIn that in the community that my wife and I now live in is actually the community that Andrew grew up in. And not only that, but one of Andrew's best childhood friends is actually my next door neighbor. Now, I don't tell that story for the sake of it being a story. I tell that because doesn't that define what agriculture is? That at the end of the day, we're really one family. So with that, Andrew, my friend, it's my honor to introduce you this morning. Andrew.
Thank you. Wow, that's pretty loud. Thank you. This morning we are going to talk about how to utilize newer equipment in older facilities, but like we mentioned, make sure you got the clicker going. Safety moment. My company also just starts off the safety moment every meeting. You know, we also have a quality moment. This week's was scaffolding. The one thing that I didn't know that I did learn with scaffolding is that there's really no legal requirements to tag them. Now, I thought it was a requirement to have a green tag, yellow tag, red tag. And we talked about how you read through it, and I'm sure many of you guys here have either erected scaffolding, been on scaffolding, but I didn't realize there was no legal requirements for that. So that was just something that now I take an even closer look at the scaffolding, knowing that, hey, it didn't have to be tagged, or it could be tagged wrong and still, not be an issue, an OSHA incident or something like that. So that's just my thing we learned this morning or this week. Things we're going to talk about today is planning, part one. Whenever we're looking at putting something new into something old, it's actually, you do more planning than a green field. Permitting, this is something that some places will miss a little because we already have a piece of equipment in here, or we're just going to retrofit or something like that. What data we got to gather, and then planning two after we get our data, our engineering and construction. So when we're looking at planning, is it just one piece of equipment? Is it your reclaim belt? It's been open, it's like I said, 1894, you still got cast iron idlers out there. Is it a whole process line? You're taking it from the conveyors, up the bucket elevator, out, you want to increase capacity. What are we looking at doing? Is it like in kind? Or like I said, are we doing a 24-inch belt, 36, do we maybe want to go to 36 to a 42? These are some of the things that, we can fit in here as we're looking at things. Who are the stakeholders? Operations, obviously, maintenance, obviously, but there's other stakeholders in there. The people that bring you your grain, the people that you're selling your grain to, right? How does this process, how does the install of this equipment affect their process? Who are the gatekeepers for funding? Sometimes you can do it under a maintenance, project, or it's got a capital project, and, sometimes you got to figure out, hey, accounting, we're going to do this and we're going to increase production by 20%. Or we're going to not have to clean up after every barge or ship or truck that we load out because of spillage. So we're going to reduce our, the amount of money we're going to be putting into the facility for cleanup, or we're going to increase production. So that one there on the gatekeepers, I actually like running the numbers to show them this is not just about upgrading new equipment. Anytime we put in new equipment, we need to look at other factors of, can we increase by 10% or 20, right? Or are we going to reduce maintenance on this thing? Are we going to increase reliability? That's stuff the accountants really like to see, and you can put $1 on there. And we like to say, if you can get a half a penny per bushel or a penny per bushel, how much money is that in an entire year to a facility? And then do we have time and plan to perform the project, right? You could be, this is the heart line of your facility. So we know we're going to have this outage, you're going to do it during this time or whatever, but can we get it out and back in and still keep production going? Can we still keep it, on task, making money? I mean, the whole job out here is, yes, we're doing grain, processing grain, but we need to make money and we need to be able to do it in a timely manner. So these are some of the things we got to look at. Permitting. Now, permitting is something, land, water, fire, sounds like a, 1970s band, Earth, Wind, and Fire. So we've got to look at what all we're doing. Even if we're changing something like in kind, the water runoff could change, right? Your dust emissions, because now all of a sudden we're putting a point source in here. Do we have to have a new air permitting? Do we have to upgrade it, decrease it? Building, a fire. The one thing I think, if I can get to that link, how do I get to that link? Yeah, click on that one. So one thing I did realize that if you click here and scroll down, you can go to, in the scroll down please. You can click on your individual states and see what kind of environmental permits that you need. Each state is different. You've got federal, you've got state, there's also county, local, parish. And you guys do any work down in Louisiana, you know that the local parish, it could be the one that can stop you. So this is something I like to hear. You can go in here, click on it, it'll show you what all different areas you need to have. If you click on Nebraska or Oklahoma, it doesn't matter, it'll pop up. Here's what you need to have. You scroll down, you can say, yep, check, I got this one, check, I got that one. So here we go through each little county. All right, we can go back to the presentation. Oh, this is going to be fun. And also, we won't click on the Corps of Army Engineers. Anytime you're near the river, which a lot of us are, you got to get their buy-in. Now, everyone thinks that the Corps of Engineers is the one you have to satisfy to do a lot of this stuff. And you can be putting up a tank near the Corps of Engineers, and they say, yep, you can put it this close to this spot here. And you get 90% of the way done, and fire marshal comes by, says, oh, no, you've got to move this. So you really need to check off every little detail. And I will say, I think the fire marshal needs to be your best friend, because he's the one that can walk in and shut your place down faster than probably anyone else. And everyone always forgets about the fire marshal. You really need to engage the fire marshal early on in your planning, right? Invite him to a barbecue, a cookout, have him walk it down, right? Because he's the one that's going to come through and yay or nay any of these modifications, especially with the changing codes, right? We have a bunch of changing codes. This is being increased safety. So don't just look at your environmental, your earth, wind, and fire. Corps of Engineers, there's building permit people, but the fire marshal, because he'll do your building, he'll do your facility, he'll do your tanks. So when we do with a state local, but which one do we do first? Who trumps who, right? And that's the hard part is, all right, do all of them, agree with each other, right? Does our electrical agree with this over here, right? Again, the fire marshal, the open box, so when we look at it, you've got to put them all together and like engineering and construction, do the best we can with what we've got. But sometimes it'll make you feel like you're just running around in circles. Man, all we're doing here is which one's right, which one's wrong. So really writing it down and planning it before starting a project is always a good thing to do. So data gathering. We want to verify what it is we're upgrading or we're changing, right? Too many times I've heard, oh, this thing can do 40,000 bushels an hour, right? And we're planning a project and we like to run simulations on what they currently have, right? And see if what they're telling us actually is going to work or is working. And we could not get 40,000. Man, we're going back for, so finally I go into the terminal, I actually go to the guys that are operating, and I said, hey, they say that conveyor can do 40,000 bushels an hour. Drawings show it, the size, belt speed, everything technically says it can. They're like, no, we better get 28 out of it. We're lucky to get 32. All right, so here we're going to change a conveyor that, they want to get 40,000 out of it, but they can't even get 28. So what's the problem? The problem is actually the discharge of their inlet. But when we're looking at upgrading, we really need to see what is it operating at? What is the people, used to operating at? A lot of the operators will back it back down because they don't want to have a spillage. They want to clean up. So they're not running at the highest capacity, right? So really every terminal should be pushing highest capacity. But a lot of people are worried about upset and, and downtime. So what is actually happening versus the drawings? Verify demo and install times, right? When we're looking at this, is it one piece of equipment? That might be easy. Do we got to upgrade a horsepower motor? Got to upgrade electrical bucket? Looking at each time. If it's a whole process line, from rail pit, truck pit to barge load out, well, that's a big outage, right? So how much is it going to be down? Got to go back to your stakeholders, right? Got to go back to the purse and say, hey, we're going to be offline this long. Where's the commodities going to go? You got to have a plan for, let's say something happens and you don't come back online, right? What's the fallback? I know everyone here has every project always lands on time and on budget, never goes past that. Always plan for a contingency of 2 to 3 months after that. Look at the current equipment deliveries. Some of you guys out here like particular vendors, right? And some of them are backed up. COVID caused a massive chain, cascading effect. Bearings, I've heard several fabricators, we got all the steel, we just can't get bearings and chains, or we can't get belt or buckets. Lead times are coming up, but whenever, your drag chain or your belt conveyor is 28 weeks, okay, that makes a difference, right? And you got to get your order in to start that 28 weeks, right? So the more you plan up front, the earlier you plan, the better it is. Check with local installers, right? The contractors. I know down in the Gulf South, they like to do turnarounds all at the same time. There's only so many contractors down there, and every one of them wants to do their shutdown right before harvest, right? I assume the same thing up here. A little more spread out, but your resources are spread out, right? Sometimes it's nice to talk to your neighbor facilities and plan the outage so that you can just, have the same contractor go back and forth. But they may be booked, right? Getting people to work these days can be even difficult. Do they have enough manpower for this, right? Do we got to bring in 2 or 3 different contractors? So this is part of the pregame. We got to get all this stuff written out, listed, little, chart we'll call it. Looking at controls and automation. You got a facility built in 1920, man, and barely has pull cords, right? Barely has monitoring systems. Now we're putting in a new system. We can do bearing monitors, motor temperatures, gearboxes, all this, PNID, sensory stuff. Do you need to upgrade that, right? Is that inside the budget, or is that going to be a planned later? Running wire, fiber, all that takes a lot. We always want to make everything more safe, so I hope that the controls and automation needs to change. I hope we have more safety devices on it, more sensors. We need to have trained people in new skill sets with this, right? Putting something in, a new bulk weigher or a dryer, maybe you didn't have one before. But as we're putting these things in, what skill sets need to be done? Do we need to train these people? Do we bring in outside trainers, or we bring someone from corporate? Will cause shutdown downstream. I've got the conveyor in the basement, and I'm increasing 20% capacity, right? But my bucket elevator can't, and I'm stuck inside of a concrete, silo part. Oh, maybe we change the style of the bucket. Maybe we change the speed a little bit, right? Can we get 20% out of that? So sometimes planning the upgrades can cause the bottleneck further down, right? So maybe when you're looking at doing it one piece at a time, you start at the beginning, and you don't see the improvement until you get every one of those pieces done, right? So you may not be able to do it all in one setting, but, and is it more than the equipment, right? Transfers, structural, and electrical, usually are some of the things that forgotten, that are forgotten about. Getting the material into the equipment and out of the equipment is the hardest part. Once it's on the equipment, inside the drag, belt, or bucket, usually behaves pretty good. But your bottlenecks, your wear points, your cleanups, where all your shovels are, brooms, are almost always at the tail, where it inlet, at the inlet of a conveyor or a discharge. And sometimes that's what needs to be fixed. You can increase throughput just by fixing those things. Structural, going from an open belt conveyor, stringer idlers, maybe hoop cover, now to a fully enclosed belt conveyor, right? Now all of a sudden I got weight. I got to take in an upset condition, right? What is my now new weight and load on there? Seismic, wind loads, things like that. When you get to so much modifications, now you got to bring it up to code, right? So now I got an enclosed conveyor on something that was open. Now I got to reinforce this. What's the new hurricane wind loads? They've gone up since the 20s, right? 1920s. Same thing with electrical, all right? We touch it so much. Now we upgrade all of this, right? So not just one piece of equipment, especially in an aging facility, you've got to look at everything that goes through here, from transfer, structural, electrical, controls and automation, which, hopefully we're upgrading all those things. And everyone's going, yep, yeah, I hear you. Kind of like that safety thing at JSA, are you lucky or are you good, right? So let's see if we can plan some of that out. Planning part 2. Now we have all the data, we know what we're doing, and we're like, all right, we're going to put this together. But it's like a puzzle. We got to look at a system approach, right? If I start here, how does it affect here? How does it affect here, right? Individual pieces are the ones you hear, it broke down, we've got to fix this, I'm tired of replacing this belt, whatever. But what does it do for the whole system? Does everything fit together, both figuratively and literally? And I'm going to get to the literally here in a minute. But how do we know this before we spend all this money, right? Before we buy the equipment, before it's on site. And with some modern technologies, there's a great way of doing this. Laser point cloud scanning, almost everyone's heard of that or used that recently. It's not really new these days anymore. 3D modeling, existing and new, same thing. A lot of people are doing it. Virtual reality review and augmented reality view, a lot of places are doing it, but the grain industry doesn't seem to be using it as much. And I really would like to encourage you guys to do this because when you get all the stakeholders involved in this part, the project execution part, the install, right, will go a lot smoother. You can plan these things out, and I'll show you here in a second. PLC and DCS simulations. You can go to a lot of these control people, say, hey, I'm looking to change this, want to change the process, and how would it affect it? Show me some simulations. I know some facilities have used that stuff in order to help figure to be more energy efficient, right? We get more energy efficient motors. What is my startup sequence, right? How can I help me lower my cost of energy? That penny per bushel actually came from one of the accountants at one of the big companies when they said, if you could lower my utility bill by a penny per bushel, I could save millions. Because the facilities don't see the electric bill, right? They don't see it, but the accountants do. And if you can make your facility more energy efficient, that's pennies per bushel that they like to see. So don't ever forget about your electricity, your PLC, and your programming. So this project here is one that a couple other companies said it couldn't be done, and we're like, well, we might be able to with some non-traditional pieces of equipment. So instead of just ripping everything out and trusting us, engineers never make mistakes, right? No one ever makes mistakes, right? So everything fits perfect. So we decided, all right, we're gonna model this thing. So we went in, we did a laser point cloud scan of the existing facility, and this is coming from the scales, up to the head house, to the gallery, going down through the trippers. So this was originally open belt conveyor with traveling trippers coming through there, right? So gearbox and drives further back, but they want an enclosed conveyor. So we're looking at, we model it, get structural, to put in here. So the green is new, the cyan is existing, and then any of the point cloud you see in there, obviously is the, let's see if it'll run. There we go. So what we were able to do is put this all in the model, and we were able to have maintenance and operations put on the headset and literally walk through this. Go up the stairs, how's the handrail? Is that an OSHA handrail? Actually, I'd have to measure it, but I'm going to say no. A lot of the handrails are not at the actual OSHA stair rail level. It's a guardrail. But we're actually even put up here to where the difference between the blue here in this gearbox and the gray is so we could show that we need to slide this off for maintenance. Maintenance like that because I got a gearbox up there, but I got a beam. How am I going to get that gearbox off here, right? How am I going to work on this piece of equipment? I mean, we even show nuts, bolts, right? So we come through here and you put in something funky and we can make this work. But we all the way down to notching flanges. Now nothing's been bought. All this has been planned. Now we got to look at structural. Now this was an open conveyor. Now we're fully enclosed, right? So we're starting to look at these things we mentioned. And with this, you can plan out this project. Now you get a contractor in here as well. Hey, I know I need to move this first. I can put this in second, right? It helps the mental and visual planning of trying to fit, some new equipment in an older facility, right? You'll see in here in a minute, I don't know if you can see it or not when it comes through here, we got conduits running through here, right? So now I got to find out, are they hot? Are they dead? Are they fiber optic? What are they? So we can set in here, and if you're within an inch in a model to a conduit, check that conduit because, you may be over an inch and a half, whatever, by the time you get in there. But it allows better planning and less change orders. Let's face it, change orders is usually where they're really going to try and get you. But if we can work through this and say, hey, we have all these issues to look at, before you even buy the equipment. I mean, it really helps that budgeting, right? It really helps going back and showing you've done your due diligence, right? Hey, corporate, we need the money for this. Now, this is the one that should go to the next spot. Let's see if this will do this. Go to the web part, and then that video should be able to load it up. This one, the 4D reality. Yeah, look at that. Yeah. There we go. And it should be already loaded. And then scroll down and hit the first video. So augmented reality. So we did the virtual reality, right? So here's the augmented reality, right? Oop. Back up a little. Right there. Click that. This one, I think this is used in a Microsoft Halo set. But here, you can actually, instead of the virtual reality, you can actually see it while you're standing there, while trucks are coming through. So I've got this set here. This is live. You see the steam in the background, right? So you could put this out there and see how traffic flows. Your trucks coming in and out, right? You know, fork trucks or whatever. You can see some of these upgrades while you're standing there and while you're walking around. I mean, it's almost like you could touch it in real life right there. So augmented reality, virtual reality, very similar. But it allows us to help, you know, with this. Scroll to the next one. Scroll down, please. 4D modeling. Now, if you're on a bigger project, let's say it's a whole system, you could do planning tied to a project management software thing that will help you with this week install. Where should you be, right? It has the safeties, the pros and cons, and it shows that as you get things installed, you know, this is where you're at. Now, if there's a delay, it'll kick out your schedule, right? So some of these projects you can use this where it's a lot bigger. Where, hey, man, I've got to get this in first, and then this, and we got to work for that, and it'll show your weeks, right? If you hit a delay, it'll push out the schedule and show it to that. There's one more. Scroll to the bottom. That one right here. Now, this guy, I really like this one. I never thought of it, but if you have to put in something really big, let's say you get in one of the world's biggest grain dryers, a rotary kiln, right? Not used in this industry, but all right, we got to get it on site. Your terminal's old, the facility's grown up around you, the city's grown up around you, the port, something, and you've got wires, this, we got to get this in here. So what we can do is you can scan this, and then this is driving through here. Now it's going to go up and going down the road, what are we going to hit? What do we need to move? Luckily, driving down this road, we only have to move one stop sign. We just ran that thing right over. Which that one wasn't a deal, but later in the video you're going to show where also we have to go underneath a pipe bridge. Oh man, someone's installed a pipe bridge and I got to get this sucker through here? No, do I fly it over? Probably not. So in here, there's a little, you see the light blue or light cyan on top. That's the inlet they're looking at. That hits the pipe bridge. And we're able to see this and say, oh guys, you're going to hit this, you know, or come close to it. So now we know that, hey, getting this in here, we're going to have to lower it, get a low boy or something. And, you know, you can measure all you want, but when you can throw it in here, dripping down wire, you know, power lines, we got to get that disconnected or reconnected. So again, this planning around existing stuff with the new stuff. So the new software that we've got out here, all this modeling. So yeah, here's where they're lowering for the pipe rack clearance. The more we plan and the more we use some of this technology, the faster and easier and safer the install will go. And there we go. Here's where we're hitting the pipe rack. Oh, that's not going to fit, guys. So they lower it, run it again, show the client, hey, we can get this in here, right? So now not every facility needs something like this, but it is something nice to know that, hey, we can plan this, and in particularly with your contractors. Man, I can't stress it enough to have them start using some of this stuff. Pictures 1,000 words. A model you can walk through, put your superintendent on there, he knows the job before it even comes out. All right, let's go back to the presentation. All right. So in construction, now no one's ever had that. We know what we're doing. We don't need no stinking drawings. We do this all the time, right? Are you lucky or are you good, right? I like that. But really, what we want better planning equals a better project equals a happier client. We really need to get the contractors involved earlier on. right? And actually have them sit down and either go through them or through the drawings. Had some go through, and all of a sudden you're called back up, and hey, this isn't working right. Well, they didn't field well. This field well, it's marked 3 spots on this drawing, right? So some of this is routine. Some of this we have done it all the time, but sometimes we need to go back and check. And an hour's worth of meeting just to kind of go over things can save a lot of headache, right? So what we'll do is we'll understand that, time constraint. Do we have the manpower? Do we have enough guys to do this, right? Let's say some people call in sick. We're really tight. Do we have a backup? Whether it's, the other job site or manpower or whatever, right? Understand the long-term goal. It's not just about getting it running. We want to make it quality, right? It's better and easier to do it right the first time. Align those idlers. Square up the pulleys. Because tracking that thing later, you're still going to have to do it, but let's get it close before we turn it on and wreck the brand new belt, right? Electrical, structural, mechanical controls, solid communication. It may not be just one contractor. It may have many. You guys are trying to run a facility, right? You're trying to ship grain. You're trying to make money, right? Do you have time to manage a project with 3 different contractors? Sometimes that becomes an issue. It's not the equipment getting in and out. It's herding the monkeys, right? It's, hey guys, you got to do this first, and this guy's got to do this, and this guy's got to do that. It is a solid communication, and it's coordination. So all of this needs to be done at the same time. The more you plan up front, the less you have to do, knee-jerking, things happen going, oh, that was a fiber optic cable. Damn it, didn't know that, right? Stop, get someone in here. So the more planning you do up front, the easier and faster this project will go. So whether you're doing, utilizing your shovels correctly here, hey, I only got 1 shovel, but we can still make this work. Or, we're behind and driving this pile here, we're going to have 4 guys hit at the same time, right? So there's different ways of solving the problems. But what we want is something like this. Something that's smooth, efficient, going up. We get our steel first, then we put the siding, then we do the electrical, then we do the drywall, then we do the carpet, right? So this is something that we're trying to get to on all the projects, right? And the more planning, the more involvement with everybody, the faster and better. So, conclusion is teamwork. Create a plan that everyone knows. Work the plan that everyone understands. Review the progress as a team, not individually, right? I understand we hate sitting through those meetings. I'm an electrical guy and I hate sitting through structural. Well, a structural guy says the same thing about electrical. And by the way, I'm a mechanical guy. Us mechanical guys, we rule. You guys just hold up our stuff and wire what we say, right? So, and civil guys, you're way down in the dirt. I mean, let's put it where it's at. Everyone knows to move forward, or no one does, right? Doesn't matter if I get all my steel up if I don't have electricity. Doesn't matter if I have electricity if I don't have steel there, right? Old or new, tasks are the same. So, any questions? I was going to make up for the time. We want to make sure that we're staying there on time.
Let's have a round of applause for Andrew. You went through that fast, buddy.
I talk a little fast.
No, that was fantastic. And just like with the previous speakers, I've got 2 or 3 pages of questions here, but would rather hear from you guys out here in the audience. Reggie, you like that, don't you? I'm not smart, so I write down a whole heck of a lot of stuff. Again, just raise your hands. Glenn's out here. Oh, we got Jim. We'll go ahead and start with you. So, Jim Boyd, we all know you, but just let us know who you are, bud.
Jim Voigt with GFE Solutions. So, Andrew, a question for you. A lot of our elevators aren't that complex.
Okay.
In the golf elevators, that's one thing, but we come up to a country elevator. We got a simple project. I'm adding a bin, so I got to extend a fill and bring a ring claim back in. Can I cost justify all the simulation on a project that? At what point is that additional cost justifiable?
So, great question, because that's where it goes back to is it one piece of equipment or is it a full process, right? I really think the pricing of some of this has gotten down as far as like the laser scanning or something like that. But on some of it, if it's a simple project, maybe that's not what you want to do with the simulation. Drawings, field measurements, things like that. When I think when you get in tight stuff, and you're getting into where there's conduits, water hoses, fire lines, things like that, that's where I think when you look at the cost, okay, maybe it's this cost, but what if we hit something? what's the cost if I don't plan this out? And you've got to weigh that, right? Is we didn't realize that the flanges of the conveyor or the hoops or the bolts would get into the concrete or something like that. Now I got to knock it out. So there is a balance between that on what's the risk when you plan the job and how can we mitigate those risks. And some of it's, no, we don't need this technology. Absolutely.
Again, if you've got questions, just raise your hand. Glenn will get to you. Andrew, I've got a couple for you. The latter part of your presentation was one that really hit home to me about going into these older facilities. For those in the audience that know me, you know that I spent the last 20 years in the ethanol industry. Nearly 91% of U.S. ethanol production was built in the last 20 years in the form of these dry grind facilities. And there's another common denominator. The overwhelming majority of those are not only built in rural America, but they're built in the middle of cornfields, right? So it's open. There's a lot of space. There's opportunity for expansion. As I mentioned before, Joe and Ann spoke this morning, that's not the way a lot of our grain elevators are. And again, one very close to my home, the original grain silos were built in 1896 and are still being utilized. And the difference today between 1896 is an entire city has been built around those original silos. So, Andrew, where do you start? That facility calls you. You're looking at something that is 130 years old. That's one thing.
Yeah.
But an entire city has been built around it. Where do you start?
Well, starting with the planning of it, with the what is it you're going to do? All right. So let's say it's a bigger project, right? You're going to upgrade a dryer or scales. One, looking at, can the existing structure hold it, right? We've had some of those from 1906, and they put a big cleaning thing on top. Well, that didn't work out so good, right? So with the planning, the city ordinance, I would actually go to the city first and say, hey, we're looking at doing this. You grew up around us. We haven't changed. You have changed. What do we need to know before we start planning this, right? Sometimes when you're doing things, there's one place I know in particular, they were building and expanding, and the city was watching them. And they were inside the city now, and they got all done, and they came knocking on the door and said, where's your building permit? And they're like, what? We've been here. We're doing this. No, where's your building permit? So the fine was they had to put a park up somewhere in this little town. So I would start on, especially the smaller towns, is, hey, city, what are my rules? Where are my boundaries, right? And what are any new codes or things like that? Do I need a building permit, right? It's my property. I can put this up here. No, I got to have a permit. So I would start with those kind of things. Start with the city first. Utilities, hey, things have changed. I don't know what all, for gas line for a dryer. Do we have enough gas, right? So these are some things you got to check. Electricity, that's the other part is, if I'm putting in an expansion, do I have enough power on that grid? Do I have enough for my transformer? So I'll kind of start with the basics, the earth, wind, and fire, put on the song, and start there with the permitting.
Very good. Reggie, I can't help it. I keep seeing your facial expressions because since we live in the same area, I think you might be aware of the facility I'm talking about. And it's not a Bungie one, but I think you know exactly what I'm talking about. Again, questions, Glenn will find you. Okay, so now, Andrew, let's go the next step, right? We figured out how we're going to get into this facility, but now it's more complicated. There are multiple areas in the process that's needing replaced, right? So you're in the facility, but you got multiple areas. Where do you start now that you're in there and you've got multiple areas that are needing replacement?
So I learned this from a guy that I've been talking to recently, who he went out from the engineering construction world to an owner-operator. And he goes, man, when I was on this side over here, I thought, just where you start, we start at the beginning and we upgrade. He goes, now since I'm over here in the owner and operator, it's like, I'd like to do that, but I don't have the money for this one. I'd like to do that, but I don't have the money for this one. So when you have multiple things you need to upgrade, you actually do need to have, almost like a big chart, up on the wall and say, okay, here's all the items, here's the estimated cost. Where do I start with my stakeholders and my purse holders, right? So what can I do? Not just what do I want to do. And if I can do this, does it make sense to do this one first? Or do I do this one first? We have one, they were looking at, trying to stop spillage, reclaiming from the silos, right? And I said, well, again, we don't probably increase throughput, all that stuff. Oh, if you increase throughput, it's really going to jack me up down here. So, okay, well, let's go down here first. So some of it is, I've got a lot to do, but which is beneficial and what's not going to cause problems later, but also what do I have the money for? What's going to get approved and what can I get done?
Very good. So let's think about this, right? Anytime that we have a client, they're watching the clock, they're watching the calendar, they're watching the dollars, they're wanting to get this project started because they've got an ideal project completion date in mind. So the next question is, and I can't wait to see Ann Cook's facial expression on this because there certainly is a safety component to this, Ann, and Joe, if you're still in the room. But the question, Andrew, is this. All these demands from the client to get started, because we got to get it done. So how far into the planning process are you before you actually start the project? So you're planning, but they want you to get started on the completion of the project. So how far into planning do we actually start?
To do it smoothly, you really need to get through many of those first steps that I mentioned, all the way through, hey guys, what is it we're going to have to take out? Demo, install. So before we get started, you need the guys, the contractors, the guys who are going to install it to also come look at this. And I know there's a date that we got to hit because we need to be up and running because harvest is coming, right? But if we don't plan it right, if we don't step back and say, guys, I know you want me to get this done, and the best and fastest way for me to get done and not run into issues is to plan it. Spend 80% of the time kind of planning, and it only will take you 10%. If you spend 10% of the time planning, it's going to take you 80% to get that done. So really, as much as the client's wanting to push, I'd push back and say, if you want the installer, because they're the key, right? They're the ones that are going to put it up and make it work and turn it on and everything goes smooth, right? I don't know if anyone's had a project like that, but I'd love to find one. But the more you plan it, the faster the install goes. And with some of this stuff I've shown you, the guys can even see, oh, I can do this, I can stage a crew here, I can have so many guys fit here, we can do this here. The planning, really got to push it. And you got to push back on the client because as soon as you cave to that, Murphy's Law, something's going to come up.
Very, very good. And there obviously is a safety component to that, right? That's always taken into account. You do it safely. Andrew, another one. So you've got everything laid out. You've got everything designed. But Andrew, tell us those 2 or 3 we must know things. I can't stand that word. But those 2 or 3 must know things before you actually implement the process by which you've designed and built.
Well, the things that you absolutely have to know is, is it to code, right? Are we cutting any corners? Are we current code? Is there all the safety boxes checked? Is it going to be, installed right? So when we're looking at it, there's permitting, which is one thing, and there's code compliance, right? Some of that is intertwined, but, are we going to meet this? Do we have the right people? The right people on the bus, but the right people in the right bus seat too, right? So when we're working with we're installing a reclaim conveyor, whatever, what do we need to have? And making sure, and actually writing it down, and I'm not a big person that likes to write things down, but having a written plan before we start going through and forward, to me is key. I mean, again, I talk about a whiteboard or a Post-it note, some big projects work best when you have those Post-it notes because you can move it around. But if you don't have a plan, and you're not, everything's code, everything's compliant, safety, it doesn't matter if you start it or not. It's not going to work out well.
Very good. Any questions for Andrew? Glenn, just your name, who you're with, if you don't mind.
Josh Book, CGB, Consolidated Grain and Barge, do projects. Kind of just more a basic question. What software packages have you had the most success with all the new 3D, 4D stuff coming out?
Yeah.
Whether it's project management software or just your modeling software.
So it really, well, a couple different ways we'll answer that one. Depends on the size of the project for the project software, right? So we got some that do just Microsoft Project, some we just, basically a Gantt chart. We also use Aspen for some of the much bigger ones. That 4D rendering you saw, 4D modeling, that's tied into a Nancy, I think it's called a, forgot the name of Aspen, yeah. As far as integrating the laser point cloud scan and all that modeling, Inventor and Navisworks are one of the best. We'll model equipment in SolidWorks and bring it into Inventor, just because SolidWorks does, mechanical modeling better. But we actually use almost 3 different softwares. But Inventor, and then for the VR headset, it's a Faro or a Cyclone. But yeah, some software works better with the 3D and some does not, but we use a multiple. So, and again, it just depends on what we're doing.
Very good. Any other questions for Andrew? Any at all? Okay, seeing none. Andrew, thank you very much. Let's have a round of applause for Andrew.
Thank you.
Very good.